Welcome back to Max Made Easy with Abby, where your hatred for Max turns to love. So today we shall concentrate on class 10 syllabus. So we'll go on with chapter 1, relation and functions. So if you haven't familiarized with the concept of set theory in class 9, go check out the channel, click on the description, or you can click on the annotation above. So we'll move on with what are all the contents inside this chapter. So you'll be having cross product, relation, functions, types of functions, composition of functions, and graphs of certain functions. So since this is going to be the first video, we'll move on with cross product first. So I think you would have been into an cinema theater or in a big concert hall. You would have been seated in a particular position or in a particular seat, I would say. So let's consider you have been sitting in this seat, right? So this seat is actually the fourth seat in the fifth row. So note that each and every particular seat in this big hall is numbered for easy identification, right? So how would you actually represent this mathematically? There stands a question now for you. Also, if you have been traveling in aeroplane, so you would have a number of seats here. So you have 9 seats in a row. Let's number them like A, B, C, D, E, F, G, H, I, and you have like many rows here. Okay, so let's consider if your seat number is 26I, so you will be going to the 26th row and occupy a window seat, since I is the end side of that plane. So suppose if you occupy the seat number 25E, you will be going to 25th row and you will be sitting somewhere else in the middle, right? So this is how the airplane ticketing system enables you to find a seat in your aeroplane easily, rather than hushing into the aeroplane like where's my seat, where's my seat, where's my seat. So how do you represent these mathematically? Yes, you're correct. You'll be using cross product. So unlike set union, set intersection and set difference you would have been learnt in class 9, you are going to learn a new concept or a new operation on set that is called as a cross product. So what do you mean by a cross product? So let's consider two non-empty set. I repeat, let's consider two non-empty set. So the cross product of AB is defined as A cross B equals the set of the ordered pair AB such that element A belongs to the set A and element B belongs to the set B, right? So the cross product results in a collection of ordered pairs. Ordered pair represents positions. So let me clear with this. So with an examples, let's consider the set A to be 1, 2, 3, and let's consider the set B to be 4, 5, 6. So let's find what is A cross B. By definition, we have A cross B equals the set of collection of ordered pairs AB such that A belongs to the set A and the element B belongs to the set B. We have A equals the set 1, 2, 3 and the set B equals 4, 5, 6. So what you would do is pick an element A from the set A. So let's pick one here, name it as A. So you have found what's A here and you have to find B. So you have three choices to find B. So you can pair 1 with 4, you can pair 1 with 5, you can pair 1 with 6. And if you take the element A as 2, so you can pair 2 with 4, you can pair 2 with 5, you can pair 2 with 6. And let's take element 3 here. So this element 3 could be paired with the set B as 3, 4, and 3 could be paired with 5 and 3 could be paired with 6. So that's going to be your A cross B. So A cross B is nothing but, let me repeat again, that's going to be the collection of ordered pairs which represents positions. So let's consider a small note here. So the cardinality of the set A is 3 and the cardinality of the set B is 3. So let's consider the cardinality of the A cross B. The set A cross B has the cardinality 9, which is actually multiplying the cardinalities of the set individually. So n of A cross B equals n of A times n of B. So can you extend it up to n set? Yes, of course. So the number of elements in the cross product containing n set will be equal to the product of the cardinality of the set individually. So as I was saying that cross product is going to be positioning of elements. Let's see what are all the position it's going to take. So we have the set A along x-axis and we have the set B along y-axis with some extensions. So the first element is 1, 4. So 1, 4 lies here. 1, 5 lies here, 1, 6 lies here, 2, 4 lies here, 2, 5 lies here, 2, 6 lies here, 3, 4 lies here, 3, 5 lies here, and 3, 6 lies here. So let's consider this graph sheet is going to be your cinema theater and you are booked to watch a movie here. So if you want a wide presentation of that particular movie, or you have the sound effects in a movie theater, I suppose. So if you want some particular place to be seated so that you gain all these attractions, that's nothing but your center seat 2, 5. So how do you pick up that seat 2, 5? Go to the second row, pick the fifth seat. So that's going to be your place where you get wonders of that movie, right? So this is how you actually interpret a cross product. So let's consider, let's actually extend the set A to real number and set B to real number. So let's consider the set A as a real number set and set B is going to be again the real number set. So we defined the cross product of the set AB as the elements of as the ordered pair AB such that A belongs to the set A, B belongs to set B. Since the set A and set B here is going to be your real numbers, so the cross product of real numbers is going to be the ordered pair of real numbers. So A comma B, the cross product of these two real numbers will be actually the ordered pair A comma B, where A and B belongs to real numbers and we denote that as R square. So what do you mean by that? So this is actually your x-axis, or we can say the set of real numbers which actually extend from minus infinity to plus infinity. And let's also consider the y-axis, or again it's going to be a real number line from minus infinity to plus infinity. You can mark points on it such that you can cover all the points in this coordinate system. So we say that R square is going to make a Cartesian coordinate system. So this is the extension of a smaller set to a real number system, right? Or any graph you plot is going to be a subset of this R square. Let's consider a situation like this. Consider any one set which does not contain any element. So that's going to be actually an empty set. So the cardinality of empty set is going to be 0. So let n of A equal to 0. If such is the case, what is the cardinality of A cross B? So we actually noted that A cross B is nothing but the pairing of elements from A to B. Since A is empty, you have no elements to pair from A, so that the end result of the cross product is going to be a null set, or the cardinality of that particular set is going to be 0. So we'll discuss in detail now. Even if any one set is empty, or we shall say it as a null set, also it is represented by phi, the cross product does not exist. That is, A cross B is going to be an empty set if either A is pi or B is pi, or if either A is an empty set or B is an empty set. So let's see some of the properties of cross product. So cross product is not commutative. Likewise, let's see the example here. So we took A equals 1, 2, 3 and B equals 4, 5, 6. So we also defined that A cross B will be equal to the ordered pair 1, 4, the ordered pair 1, 5, the ordered pair 1, 6 and such goes on till the last element. Let's actually interchange the cross product like B cross A. So we can find A cross B is not equal to B cross A. In general, A cross B is not equal to B cross A unless you cross product it with the same set. If you cross product with the same set, you would have A cross B equal to B cross A. But we shall notice that the number of elements in A cross B is equal to the number of elements in B cross A. And the operation cross product is distributive over union, intersection and difference. That is, A cross B union C is equal to A cross B union A cross C. A cross B intersection C is equal to A cross B intersection A cross C. And A cross B minus C or A cross B difference C is equal to A cross B difference A cross C. So let's summarize what we have learned in this module. So cross product of any two non-empty set is defined as A cross B equals the set of all ordered pairs AB such that A belongs to A, that is A belongs to the set A and B belongs to the set B. And of A cross B, that is the cardinality of the cross product A cross B, will be equal to the cardinalities of the set individually. And the 2D Cartesian plane is the cross product of real numbers over real numbers. And finally, we saw certain properties for cross product. So with this, we end this module. So take care, bye bye, see you in the next video.